Okay, I wanted to address problem number 27 because a lot of textbooks would not do what your book does, and so we're going to go ahead and look at it. I've got 1 minus 3 log 5x. Now we know that 3 was an exponent on the x, and by the way, what I'm doing here is I'm condensing the log. Your book instructions say express as a logarithm of a single number or expression. That could also, the instructions could have said condense the log, stick it all together as one log, okay? So I've got a cubed here because that exponent's going to go on that x. Now, I can't combine these two numbers unless I can rewrite one as a log base 5. A lot of books wouldn't even have you do this. It's kind of interesting to me. This is the first time I've used this book, and it's actually a pretty good idea what they've done here. All right, so I could put things together if I could just express 1 as a log base 5. So I want log of some base 5 of some number here to be 1. Because remember, a logarithm is a missing exponent, and when this is the 1 that we're seeing in the problem here. Well, if you think about this, again, if you need to label this, do this. This is log A, B equals C, and we're going to rewrite this as I, C, a B. Well, the A is 5, and the C over here is 1, so that missing number in the middle is 5. So what that basically tells me is I can rewrite 1 as log 5, 5. That's the same thing as 1. So I'm going to take this 1 out here, and I'm going to replace it with log 5, 5. We talked about this in another video, that we know that if we've got the same two numbers here and here, that it's always 1 anyway. Well, I had to have log base 5 if I was going to combine these. Now that I've got these two expressions written as log base 5s, you see the subtraction sign. That reminds us that I can write it as one logarithm, and the first thing goes on top, and the second term goes on the bottom. So we'll put x cubed on the bottom, and we're actually done. That's what we would do with 27. Let's look next. 31 is log 4 of 40 minus log 4 of 5. Okay, if you tried to evaluate each one of these logs separately, you wouldn't get anywhere. This is one of the reasons why we like to put stuff together. The instructions just say simplify, so you got to go, oh, well, I can't do anything independently to each log and get a nice pretty number. So maybe I could put them together and get a nice pretty number because they do have the same base of 4 here. So let's do that. We see that we have this subtraction sign here. That means we could rewrite it in terms of a fraction. It would be log base 4 of 40 over 5. That's the quotient rule. Okay. Now, now that we wrote it as 40 over 5, we can go ahead and simplify that. 40 over 5 is actually 8, isn't it? Okay. Now they want us to simplify it all the way. They want a number here. They want to know what is this equal to. So let's do this. Let me put it's equal to some number C. Okay. Because a log is a missing exponent, and if I label this log A, B equals C, I can rewrite it in exponential form I, C, a B. Okay, so the A is 4, and then C is the missing thing we want to know, and then our B is 8. And you look at 4 and 8 and you say, maybe I don't know what power to raise 4 to get 8. Well, the problem we're having here is these aren't in the same base, and I can't write 8 in terms of 4 maybe really easily, but here's what I could do. Couldn't I rewrite both of them in terms of 2 to some power? For instance, let me rewrite it up here. 4 could be written as 2 squared, and 8 could be written as 2 cubed. Okay? So now I have a power to a power over here, so I can simplify that. That becomes 2 to the 2c power, because we multiply when we have a power over power. And on the right-hand side, we just have 2 cubed. Now we know these two sides are equal. They're the same number, and they have the same base, so that tells us that these two exponents must be equal. And if they're equal, let me set them equal to each other, because that'll help me know what C is, and that's what we're trying to find in the end is that's actually our answer. That was over here. I called that, that's what got us started on this long journey here. So if I'm trying to solve for C, all I got to do is divide both sides by 2, and I get C is 3/2. That was this right here. Remember, that's actually the answer to our problem here. I thought we'd look at 33. 33 tells us to solve this log a. We don't even know what the base is. It's just a. Log a x equal 2 log a 3 plus log a 5. And we're supposed to find out what, we're supposed to solve the equation, which usually means find x, right? All right, so let's look at this. You go, well, what am I supposed to do here? I don't know how to simplify any of this. I don't even have the base. Well, that's okay. Let's go look at the second side. At least on the second side, is there anything you could do? Yeah, we could condense all this. Maybe that's going to help me. I don't know, but it's something I can try, so let's try that. If I'm going to condense this, we know the 2 is an exponent on the 3, so let me rewrite that as log a 3 squared, and I'll just put plus log a 5. Now, 3 squared was actually just, let's go ahead and just write it as 9, log a 9 plus log a 5. Now that I've got it like that, I'm trying to find out what x is. You know what? I look on that right-hand side. There's still some stuff I can do because I'm adding those 2 logs, and the rule says that if I'm adding 2 logs that have the same base, I can put it together into one log by multiplying it. So I get log, on the right-hand side, I'm going to have log a, and 9 times 5 is 45. Well, if log a of some number is equal to log a of 45, then that missing number must be 45. So my solution here is x is 45. That's how you solve these things, okay? Let's do 35 also. So you just keep trying to put stuff together until you can figure out what's going on, because again, they're trying to give you something here where you don't even know what the base is. So you got log, on 35, log b of x plus 3 equals to log b of 8 minus log b of 2. Okay? Trying to find what x is. I see they all have the same base. And I look at the right-hand side, and I don't know where to start, except that maybe I could put those two together, and that might get me somewhere. So let's try it. Log b8 minus log b2, since we're subtracting, remember that is the quotient rule where we can put this together into one logarithm and put the first number on top and the second number in the denominator of the fraction. And when I look at that, I go, oh, well, we can simplify that because 8 divided by 2 is 4. Okay, so I've got 2 things that are equal. I've got a log base b on both sides, and if you look here, the x plus 3 and the 4, they match up, don't they? Well, that must mean that x plus 3 is equal to 4. So if we want to find out what x is, we can. We can say, well, all I've got to do to find out what x is just subtract 3 from both sides, and I get x equal 1. So my solution here is 1.